Hey everyone, welcome back to the Exponential Edge video series. Today we're diving into a topic that's been getting a lot of attention, layer 2 blockchains and their economics. So even if you've been following the blockchain space for a while, you know about the problem that all blockchains face, which is scalability. Transaction fees can be high and the network gets congested when things heat up on the blockchain. But there's a solution to this developed by Ethereum, which are layer 2 blockchains. But before we dive into the specifics of that, let's quickly cover some basics about blockchains and what we mean when we talk about block space. So at its simplest, a blockchain is like a marketplace for block space. Think of it like real estate. There's only so much space available, and as demand goes up for those limited space, so do the prices. This is what we see happening with gas fees on networks like Ethereum and like Bitcoin. So for Bitcoin, each block has about 1 megabyte of space, which is enough to fit roughly 2,000 transactions. Because space is limited, users pay gas fees to get their transactions included. It's how blockchains make money. If you look at how much users have paid in fees to Ethereum in its L2 rollups over time, you'll notice some big swings and dips. During the bull market in late 2021, fees skyrocketed because there was so many people using the network at the same time. At its peak, users were paying nearly $2 billion to Ethereum. You fast forward to now in August 2024, where fees have dipped to their lowest points, and users are still paying over $50 million just to get their transactions processed on ETH and its L2 rollups. So what does this mean for Ethereum? Well, like any business, Ethereum makes money from these fees, but it also has costs. The costs related to Ethereum are mainly two components. First, you're paying validators to process transactions, and they get a portion of the fee revenue. And second is you issue new ETH rewards, kind of like stock-based compensation as additional incentive. The overall takeaway here is that Ethereum operates with a gross margin of around 30% over the long term after taking into account its costs, with validators taking about 70% of the revenue. What's interesting is that Ethereum doesn't have the usual operating expenses like a traditional company. All of its costs are directly related to producing block space. Looking at this chart over here, Ethereum's profitability has taken a hit recently because gas fees have dropped while its expenses have stayed mostly the same. Lower gas fees means there's less demand for block space, which leads to cheaper fees and higher throughput. But as we head into the next bull cycle, more apps will be developed, which will lead to more users joining, and ultimately those high costs and scalability issues will return. And that's where layer 2s come in. You can think of layer 2s as the middlemen who buy block space on Ethereum's L1. They compress it and optimize it, and then they resell it to end users and applications. It's similar to how credit card companies batch transactions before sending them to banks, which reduces fees and makes everything more efficient for the average user. One of the great things about L2s is they can scale almost indefinitely. There's no hard limit on the number of transactions they can handle. So it ultimately comes down to the demand side for L2s. Of course, L2s also have their own costs. They mainly pay for call data to submit transactions back to Ethereum's L1. The fees users pay on L2s usually have two components. First, there's the L2 execution fee, which is the cost of processing your transaction on the L2 itself. And second is the L1 rollup fee, which is the cost of sending your transaction back to the L1. Now, let's talk about the value of L2 tokens today. Right now, most of these tokens are mainly used for governance, which gives holders a say in roadmap decisions. A few rollups have started to change this concept and have adopted their own native tokens to be used as gas fees. For example, Starknet and Mantle both allow their own tokens to be used as an alternative to gas fee to ETH. Even though L2 tokens rely heavily on ETH, they're finding other ways to capture value. For example, there are entities on L2s called sequencers who manage the ordering of transactions, and they collect a fee for this service. Right now, this is mostly centralized and operated by the rollups' own services, but eventually there's a potential for a fee switch proposal where some of these fees could be distributed back to its native token. Arbitrum is already exploring this with a proposal to launch a staked ARB token where holders can earn a yield by staking their tokens. While it's not tied directly to sequencer fees, it could be something that gets voted on in the future. So in conclusion, we believe that L2 scaling solutions are the key to bringing the next wave of users to crypto and DeFi. While they're definitely good for Ethereum, the value of their native tokens is still evolving. However, as more apps are built on these networks to gain more network adoption and traction, we believe the most dominant L2s are likely to see significant value accrual in the coming cycle. That's a wrap for today's discussion on L2 blockchains and their economics. If you found this helpful, don't forget to like, subscribe, and follow us to stay updated on all things DeFi.